In this video, I'm going to introduce you to multi-criteria decision analysis. This is a decision theory tool that can be used by risk managers when there's more than one criterion that's important to consider in making a decision. You are looking at a picture of Cameron Run, Virginia. And right along here, this path I'm showing you is a stream called Cameron Run. Over the years, this stream has caused problems in the community by flooding some of the housing areas, but it also represents potential for ecosystem restoration and urban recreation. So the U.S. Army Corps of Engineers was looking at a number of plans to address the flood risk and the potential gains to ecosystem restoration and urban recreation. So we're going to go over here and take a look at the software. I'm going to begin with this brainstorming window where you see the overall goal is to identify the best plan. Which plan is best to address these risks of loss and risks of potential gain? And you will see we have several criteria that we use to define best. One of them is the annual habitat units. This is improvements to the ecosystem. There are annual user days of urban recreation. There would be the cost of constructing and implementing, maintaining this plan. There are flood risk management reductions in flood damages that result from elements of the plans. And then there are property effects. Some of the plans improve property values, some do not. We have 8 different plans here. The details of the plans are not going to be important to us. Just understand that each of these plans is sufficiently differentiated from the other. So we have the overall hierarchy of the goal, of course, is to choose the overall goal, the best plan. These are the criteria that we use to do so. If I take a look down here at assessing the rates, we have to decide which of these criteria that we're using is most important. So I'm basically going to say that cost is equal to the benefits. And we have 4 measures of benefits here. And so I'm going to assign 25 points to each of these 4 measures and 100 points to the cost measure. So we have, in effect, said that benefits and cost are equally weighted. Now, if I go back to the structure of our model, you can see the data here. For everything but the property effects, we have numerical data. These were all estimated. If we had distributions here, we could be inserting distributions, but for simplicity, I'm foregoing that option. After I put in the data, what we essentially have then, let me go back to my brainstorming window, is we're saying these are the options that are available. And each of these options performs differently. So for plan A, you can see this is the performance of plan A for those criteria. This is the performance for plan D of these criteria. I've also gone ahead and provided weights to these different criteria. And so with the multi-criteria decision software, I'm using Logical Decisions version 7.1. What this does is it takes these data, my preferences, and when I say combine that, it ranks the alternatives. I want the overall ranking. I say that's okay. And it says based on the effects of these different plans and the relative weights of the criteria, the plan that does the best to meet all of these different criteria is plan D. You can see it scores a 0.636. Plan B is the least effective. The colors in the bars indicate the effects for the different criteria that we have. So for example, something that has cost here as purple is going to be, this is a very favorable plan in terms of cost. This plan is not doing so much for flood risk management. It has a relatively small contribution there. This plan does a great deal for flood risk management. So I can look at these and say, they're quite close, and even though plan D is best overall based on the inputs I have provided to this model, plan H is pretty close, And maybe if I judge this to be an important effect, reducing flood damages, I might move to a plan H. So what I would like you to know, without going into the software and showing you any more of the features, is simply this, that if we are going to be making decisions based on risk assessments, whether it is a single criteria, applying a rule, or using multiple criteria, we are going to have to learn how to help decision makers make more than one-dimensional decisions. There is no such thing as the number anymore, and that's one of the things that we're going to have to learn going forward.